Hi tech family, welcome to another video from eTechViral, and in this video we are going to build the simple Flutter DApp. That is our simple DApp. You can see it on the screen, but first let me tell you the tools we are going to use in this video to build that simple DApp. The first tool is we have as an editor we will use the Android Studio, and you can use any editor if you want. But in this video we are going to use the Android Studio. And this application will be in Flutter, and after that we will write a smart contract in Solidity programming language, and for that we will use an online IDE, that is our Remix IDE. And we will also use the Metamask, which is a cryptocurrency wallet. If you don't know what is Solidity, Remix IDE and that Metamask, we already have created videos on these topics, so you can simply check out on our channel, or I will give you the link in my video description. And if you have zero knowledge of these topics, so also no worry, just because we are going to start and doing things from scratch. And then we will use the infura as a service provider. What is infura, how we can use it as a service provider, it will be clear to you when we start the video and start building this simple DApp. So first let's check it out how this application works. We have the current balance 35, and simply we can select the balance from this slider we want to send and withdraw, and just to get the balance. First I want to send the 5 balance, so I have selected the 5 and I will press the send. As these are the future items, so it will take some while for opening, so I will simply press this cancel, and I have pressed this send 2 times, so when I press this get balance, obviously it will show 45 just because I have pressed it 2 times. And the next thing we have to check is that withdraw. So I want to withdraw 10 balance, so I will simply choose this 10 and withdraw. After some time it will say thanks for your transaction, and then cancel it. Again get the balance, and we got 35. Just like this application works, and we have connected it with our smart contract we have written in the Solidity programming language in the Remix IDE. So initially we have this Flutter simple application, a counter application, and first we are going to start writing our smart contract in the Remix IDE, and after that we will connect it with our Flutter application. So let's move to our Remix IDE. So if you don't know about this Remix IDE, I have created a full course on this Solidity programming language and how to use this Remix IDE. So you simply can check it out, and here you will see the contract folder. Simply open it and we will create a new folder named basic DApp. And the first thing we're gonna need is to copy these license identifier and version of the compiler, and instead of GPL we will do MIT, just like this. And then we will start creating a contract. Its name will be basic DApp. Just open the body, and first we're gonna have a state variable of type event that will be our balance, just like this. And then we will use a constructor to initialize our variable. Balance will be equal to 0, just like this. And then we are gonna have 3 functions in place. If you look at the application I have already created, you can see withdraw, send and the get balance. We are gonna have these 3 functions in place. So you'll write a function for sending, function send balance, that will take a parameter of type amount we want to send. This will be public, and simply we will do balance plus equal to amount, just like this. And the next function is withdraw, so we will again copy that function and paste it right here. Its name will be withdraw balance, and in here instead of plus equal to we will do minus equal to, just because in sending just we are adding the amount with the balance in the withdrawal, so we will simply, we know that we will subtract it, so we will do minus equal to amount. From the current balance we will subtract this amount we have passed in the parameter. So the next thing we have to do is to get the balance. Function get balance, it will take no parameters, this will be public view and returns event return the current balance. Just like this, we are going to have these three functions, and while we're drawing the balance, we will check the condition using this require. We will simply say if the balance is greater than amount, so we will throw a message not enough balance, just like this. So if this, okay, this will be a require instead of return. So if this condition was true, so it will say not enough balance, otherwise it will subtract some amount from the balance we have passed in the parameters. So let's Ctrl S to compile and then deploy it on the first Java virtual machine. So okay, deploy it, open this contract. First, when we get the balance, we have the 0 balance, and now I want to send 20 balance. Send it, and again get it. Now we have 20 balance, and when I try to withdraw some balance, let's say I want to withdraw 5, withdraw, and again check it. Now we have 15 balance. So it means our written functions send balance, withdraw balance, and get balance is correctly working. And that's our basic smart contract. We are going to connect it with our Flutter application using some tools. And this was on our JavaScript virtual machine. So let's also check it on the injected web3. So it will automatically connect with the Metamask unlock. I already have an wallet, so it says unlock. So if you don't have, you simply have to create an Metamask wallet for that. So if you don't know how to create a Metamask wallet, I already have created video on Metamask, how to use Metamask and how can we send balances using the Metamask. So simply you can watch it from my channel. And then we are successfully connected with our injected web3 Metamask. You can see it here, 0xe72 here, and also that account here. And we are on our Ring-B test network, and that's it. Now we will deploy our smart contract on that account 1. Okay, let's deploy it. It will charge some gas just because now it's doing on the real Ethereum blockchain. Confirm. And it says we on the Etherscan from here. The transaction will be in pending. Okay, it will take some time just because, as I said, it's on the real Ethereum blockchain and it's done. Okay, let's check it out also. Here it will pending, and after some time it's success. Okay, and we got our deployed contract. So when we try to send balance, let's say we are sending 30, send. For that we have to confirm and to send that much ETH and confirm. It's done. It will take some while just because now it's on Ethereum blockchain. And again it's done. We can check out the details on the Etherscan. And after that we can withdraw some balance. Let's say I want to withdraw 10 and withdraw. It will again charge some gas fee just because we have to do it. Confirm. It will again take some time, and then again a message will appear, confirm transaction. We can check out the details here. That one is success, it's also success, and these 3 transactions are success. This first one is of our deploying contract, and that is for sending, and that is for receiving. So we have done it and it's success also on the Ethereum blockchain and also on the JavaScript virtual machine. Now let's get the balance. It will again take some time. We had first 30 and we have withdrawn 10 and we got the 20 balance. So it means it's also working on the Ethereum blockchain. We have deployed it on injected web3. And after all these things has been done, it's time to create the UI for our application. So for that we have to move to our Android Studio, and we have this simple application. We have to remove all these boilerplate code from here, and again import package material dot and void our main function run app. This will run a class stateless widget my app, And now we will create a stateless widget my app just like this. And here will be material app. In the home there will be another widget home page, and let's also disable this banner debug. So for that, debug show check banner will be false just like this, and create another stateless widget home page, or let's just create another page for it. It will be pages, and inside these pages there will have the home page. And let's move this home page to here, and also import this material package. And after that just import it and press Ctrl S, and we got black UI just because it's container, so make it scaffold body, all the things will be in the column. Okay, and we got this UI. And now we will start creating the UI just like this one. So first we need an app bar here. App bar will be app bar title text app, no simple DAPP just like this, and we got the app bar. And the next thing we need is in here we need that container or a card a balance with that circular progress indicator, just because there is no internet connection for now in this app, so we need some value, integer value in here, and this current balance text in this container or a card. So for that we will have this thing. When you press Ctrl S, we got that. So just for spacing a little bit, I will wrap this container with another container, and just its margin will be edge insets dot symmetric horizontal 20, and vertically it will be 10. And just like this we got it. So we need more spacing from upside, so this will be 30, let's say. Okay, now that's correct. And the next thing we need is that slider. So after that container I will put this as a slider, and then we need that value variable, and also have to make this stateless widget to stateful widget and a value. After that will be double value equal to 0.0 just like this one. And only one error is remaining as a slider. For that we have to add an dependency. So let's just move to the pubspec.yaml file, and in the dependency right after this Flutter SDK paste this sync fusion Flutter slider, and then press pubget, and it will take a while. And it's done now. Let's move to home page again and get the dependencies, and simply import this sync fusion slider. So when you press Ctrl S hot reload, we got that slider, you can see it here. So let's active color will be the purple just like this one. Okay, now that's great, and it needs some more spacing, so we will make it 40, and now it's correct. And the next thing we need is these three buttons, so we will make an widget for that, and we will call them one by one. So let's create another directory widget, and not inside the pages but outside from it, and inside these widgets we will create a widget button container widget. And inside this we are gonna have this custom container button widget. It has some final fields, string title and color and void callback on tab. When we press this container, that will be a button, so it must have this void callback, and it has int value. So let's check in the on the enquel we have on the on tab, we have the on tab, and there is a container. Its height is 60 and its width is media query on multiply on 0.6. Its color will be color. We will specify on the home page when you call this widget, and it's in the its center there is a text, and we will also specify this text when we call this button, and there is some styling for that. So now we simply have to move to our home page, and after that slider we will put the size box height of 40, and custom container widget. It requires many fields, so its title will be for now get balance spacing here, and its color will be green. And for now this on tab will be empty, it will do nothing, so we will leave it just like this. Press Ctrl S, hot reload, and we got this button. You can check it here. Okay, we need some more spacing, so okay, let's just leave it like this. It's okay to be this. And after that we need two more buttons, so I will simply copy these two things from here and paste it again and again, and also put the comma in the last so to avoid these errors. And now let's change its colors and its title. One is send and second is withdraw, so its color is deep purple or a purple, and its color is orange. So I will change its color to deep purple accent, and this will be deep orange, and this will be send balance, and this will be withdraw. Press Ctrl S and we got these buttons. So to make them more clear, in the container we will do the main axis alignment will be base around, and that's how our UI looks like. So now the next thing we need is to change the background color. So the background color will be just like this, deep purple with opacity 0.9, and we got the same UI we have here. And also change now this deep purple to white to make it clear, and now it's correct. And after that I need some snack bars. When I press this get balance, what we will get, and when I press this send, so what snack bar we will get on the screen. So for that we need some methods in here. So our first app bar will be this app bar incorrect value dialog box. Have show the show dialog context will be this build context, and in the builder we have alert dialog. Title will be invalid title. In the content we have said please put a value greater than 0. So whenever the client or the user pass the value or set the value 0 and trying to send the balance or withdraw the balance, so it will simply say invalid value, please put the value greater than 0. And then here we'll have an action button on when the user press it, so it will simply close this dialog box. So let me show you. On send balance here we will call incorrect value dialog box, it need context, and that's correct. And for I also will paste it for the withdraw, and just like this press Ctrl S to hot reload. And when I press the send balance, just for showing you how this works, we have not passed any values for now, and it's just the UI, its backend is not completed, so we will do it in a while. And just showing you how this dialog box will looks like. It looks like invalid value, please put a value greater than 0. So just like this press OK, and that's correct dialog box. And the next dialog box we need is when value was successed, so what will happen. So for send balance we have the separate dialog box, and for withdraw we will have the separate dialog box. So for sending we will have this dialog box. It's again simply show dialog and with some padding and thanks for your transaction, and then simple a cancel button. And for withdrawal it will also be some simple dialog withdrawal dialog box, and it will simply say thanks for your withdrawal and then a simple cancel button. Let me also show you these dialog boxes just to remove them and put the send dialog box, and on withdraw it will show withdraw dialog box with context. When I press Ctrl S and try to send or press the send button, we go thanks for your transaction and cancel, withdraw, thanks for your withdrawal and cancel. And that was it for our UI. So after that we will start working on backend, and I will also show you what is infura and how can we work with that. And it's time to add some dependencies in our application, and then we will start working with our backend. So let's move to the pubspec.yaml file, and we'll need some more dependencies. I will simply paste it right after this Flutter SDK. That is flutter.env, just because we are going to save some addresses or public or private keys in our application. So for that we have to create .env file, and then we will store it inside it. It will be clear to you in a while, and we are going to use the http package and web3 dot. So let's go to the infura first, and let me show you how this infura looks like and what is it. On the browser I have searched the infura, and you have to open this https infura.io. Click this and this window will appear in front of you. So if you don't have an account, you simply have to sign up here, and if you already have and you know what is infura, so you have to log in here. First, let me tell you, the infura provides us the tools and the infrastructure that allow the developers to easily take their blockchain application from testing to scale deployment. And we are going to using the infura as service provider. We will take some APIs from here. Let me show you my account and the password. I will simply log in here. I already have created a simple DAPP, you can see it here, and now we are going to create a new project in here. You will see the button in top corner, create a project. We will select the Ethereum, and the input name will be basic DAPP. Just create it, and after some time our project will be created. It's loading for now, and we got it. Here you can see it has the project ID, project secret, and you don't have to reveal these project secret keys, so just because it's just for testing, so that's why I'm showing you this project secret key and project ID. And that's the endpoints, our APIs we're going to use in our application. And you can see it's on our mainnet, so we simply have to change it on the ring B, just because in the MetaMask, if you have seen previously, we have used the ring B network. Let me show you here also. Let's unlock this, and here you can see the ring B test network here. Now it's clear. And after that, let's move to our Android Studio, and then we are going to create a folder inside a folder, not a folder but a file .env, just like this. And we got our file .env. So we are gonna have some public and private keys in here. First thing will be metamask wallet address. So to get the metamask wallet address, move to the browser, and you simply can copy it from here, from the account, copy to clipboard, and just go and paste it right here. That's our address. And after that we need the private key of our MetaMask, and then the MetaMask private. And then to get the MetaMask private key, so you have to move to your browser again, and on the MetaMask you will see the three menu here. You can press the account details, and here you will see the export private key. So you don't have to reveal this private key of your MetaMask. You always have to keep it private for you. It's just for testing purpose. Just because I am doing this, I will export, and it wants the password. So I will copy it. It says warning, never disclose this key. Anyone with your private keys can steal any assets held in your account. So you have to be careful and don't reveal your private key of Metamask. And done it, and I have copied it. So I will paste it right here. There's the private key of my Metamask. And the next thing we need is the public and private key of our infura. So let's move to browser, and that's the project key. I will copy it to the clipboard, and I will simply type here infura project id will be equal to that id, and in infura private id will be equal to that private ID. And the next thing we need is our contract address. The contract address, to get it, move to browser, and the Remix IDE, we have deployed this contract. So simply open it, and that's the address of our contract we have deployed. So I will copy it and again move to the Android Studio, and that will be our contract address will be equal to that address. Just like this, these were some important things we need in our application, and for that we have added flutter.env package. And you also can explore this flutter.env package. It has many uses. You can explore its documentation in here. So the next thing we need is, in our application we need something to interact with our smart contract, and that will be our ABI. So what is ABI? ABI is application binary interface. To interact with our smart contract, we need this ABI code. So if you want to go in more depth in this ABI, so I have created the video on this topic, you can check it out. In that video, I have explained the ABI and bytecode in more depth. So I will copy ABI by go to the Remix IDE and go to the compile Solidity compiler. When we compile our contract, you will see the ABI and bytecode here, but we need this ABI. We will copy it to the clipboard, and in here we will create a folder that will be our assets, and inside this I will create a folder which will be abi.json. Just because the ABI is in the JSON format, I will simply paste this ABI. You can see it here. It has UN256 amount and its type is UN256. That is for our this balance and send balance. You can see it has all the details to interact with our smart contract functions, get balance, that is non-payable, withdrawal balance, and all the things we are gonna need. So after that you have to move to your pubspec.yml to enable these assets. You have to uncomment these assets from here and simply do .env just like this, and then press the pubget. And these were some important things to interact with our smart contract, and this env file and this ABI JSON. So now we will create another folder in our application models. I will name it, and it will be our Ethereum utils. So it says get the dependencies just because the spec has edited. So let's okay, get the dependency. So now it's time to start working on the backend. Before starting, the remaining thing I have forgot in starting. So if you want to push your application on GitHub, so and you don't want to share these things, these private things to the people, so you have to move to the git ignore, and on top of that you have to ignore .env files. So when you push the code on GitHub, so that .env file will not push with them. That was another important thing you must have to know. And next, move to the Ethereum utilities, and here we are going to have a class of Ethereum utils, and here we are going to have some important things. That will be our web3 client and HTTP clients. So for that I have to import it like this, and I also have to import the HTTP as HTTP, just like this. And the next thing I need in here is the address of our contract. To get the address of the contract, we need a one line code, final contract address, and .env. I will import it, and inside this we need the name we have specified in our .env. So the contract address is that address, so I will copy this contract address, and in here I will simply paste it just like this one. And you will see we're going to use all these things later in this video. So now we need a function in here to initialize all these web3 client and HTTP package. So here will be a void function initial. To initialize the HTTP client, we're going to have HTTP client will be equal to HTTP client HTTP dot client, and just like this. And like this we have initialized our HTTP client. And the next thing we need is the API from our infura. So we will do, it will be of type string. Infura will be infura API will be equal to get the API, we have to move to our browser and simply get this first endpoint, this API, copy it and paste it like this. It will be string, sorry about that, put the semicolon in here. And now we will do 3 client will be equal to web3 client. It need a URL, so the URL will be infura API, and the HTTP client will be that HTTP client, just like this. That's our initial setup of the project. And now we need a function to get the balance. We are gonna have a method just like this one. Final contract will be await deployed contract. Just we have simply called the function of getting the deployed contract, and from the deployed contract we have get the name of our function get balance. Let's again confirm it. It's really get balance. Yes, it's get balance. And in the result we have do web3 http client.call. The contract will be contract that deployed contract, and function will be ether function. That's the name of the ether function, and params are for now a simple dynamic list. And I have done list dynamic res equal to result, and I have returned this res and 0. And now we need a get deployed contract. To get that deployed contract we need again a function for that. The function will be featured deployed contract of generic type get deployed contract and asynchronous. And here we are getting the ABI we have added in here. You can see abi.json and root bundle to load the string. And in the contract we are getting the deployed contract, a contract ABI from JSON, that will be ABI, and the name we want to give our contract. And the next is Ethereum address from hex. Here we will pass the address of our contract. I will simply pass it like this, and it's done. That's the method to get the deployed contract. And now we are gonna have 2 more functions to send the balance and withdraw the balance. First we are gonna have the send balance. So the function for sending the balance will be that function. That will be feature of generic type string send balance. It will take an amount integer, and it has the big integer amount. And here we are getting the private key of our metamask.env.metamask private key, and the deployed contract, and the name of our method. You can see it here, send balance. And the result of that web3 client send transaction. Here we are sending the transaction, so obviously we need the private key credential of this metamask. And the transaction call contract, to call the contract we need the deployed contract and the function name and the parameters we are sending from here. And the gas limits chain id will be 4, and fetch chain id from network id is false. And we have simply returned this result. Its return type is string, so we are returning the string. And the withdraw function will be similar to that, only the name will be changed. So that will be our withdraw balance. Like the similar to that, we have the big amount and key, the MetaMask private key, and the deployed contract, and here we need the Ethereum private key, and we are getting from the .env, as we have put inside this .env MetaMask private key, just like this. And that's our deployed contract and final Ethereum function. Its name is withdraw balance. Let's confirm it again. uh, Withdraw balance, you can see it here. And also again, we are sending the transaction contract, name of the ether and gas, and the parameters we want to withdraw. Chain ID, fetch chain ID network form is false, and we are returning the result. And that was our backend. You will get this code from my GitHub. At last, I will push all this code in my GitHub, so you can easily get it from here. And that was our backend. And the next step we're gonna do is to implement it inside our home page to show you it's correctly working or not, as we have seen inside this application I have created previously. Okay, so we are on our home and it's time to connect this backend with our front end. So inside the init stat, the first thing we're gonna do is we need another variable. We need to take the instance of Ethereum utilities. ETH will be equal to Ethereum utils, just like this. And the next variable we are gonna need will be a simple variable data, just like this. That will be private. And inside this init stat, we will first do ethutils.initial to initialize our HTTP client and Web3 client and the API. And then we will do ethutils.getBalance, as it is a feature we will do. So it's null. So we will do remove this arrow, and here it will be the data equal to value, and then set stat, just like this. And that was it for our init stat. And then we are gonna do is the balance, that will be data. And here we will check the condition. If the data was equal to null, so we will show the circular progress indicator, otherwise it will show the balance we have in our data. So for now it's null, so you can see the circular progress indicator in here. And inside this get balance, we will simply do the ethutils.getBalance dot, then the data will be equal to value. And okay, let's also remove this arrow from here and then set the stat, just like this. Okay, how to start the application for now. And we got an error, instance of not initializer error, just because not initializer. Let me check the main dot. Oh, we have not initialized the .env file. That, so it's just because it's not getting all the details we have specified in the .env. So I will do make it future. This will be asynchronous, and this line import it. And we have initialized .env file in our main dot. Let's again how to start the application. Hope this will works. And then we again got our application, its value is null, so it's showing the circular progress indicator. And then we have to do inside this on tap of the sand balance, we will check the condition. First make it asynchronous and await ethutils dot sand balance. Amount will be the value we get in here, and just typecast it to int, just like this. And here we will check the condition. If the value was equal to 0, we are sending, so we will show the incorrect dialog box with the context, and in the else condition we already have the send dialog box. I will simply cut and paste it here, and that was it. And also for this withdrawal, I will say just like this one, copy this, paste it right here, and also make it asynchronous, and this will be withdraw balance. And again, let's also copy these conditions from here, and on this send dialog box I will paste this and remove this withdrawal. And I think we are done. So again, how to start the application. And in the terminal, it said unhandled exception, unable to load the asset api.json. Oh, we also have to do it with this .env. So after that we will do assets just like this, and again press the pubget. Just for the confirmation, let's again pubget, just because it didn't get the values from the publicspecs.yaml in one time, so sometimes we have to do it again. Okay, it's done. Again home page, and ignore this, we have done it once. And how to start the application to check if everything is fine. And yes, now our run debug console is clear. And try to send some 5 balance. Let's press it. So I got some problem in my Android emulator. There was no internet connection, and then and we also got 20 balance in here. Just because, let me show you, I have do transaction in here, and I press this get balance, and we got the 20 balance. And here now we have 20 balance, and now our Flutter app is successfully connected with our smart contract. I have done transaction in here, and I am seeing it inside this. And before it was not showing, and there was some exceptions, and my internet was not working in my Android mobile. So now it's connected, so we are getting the 20 balance. So when I press this send again, it says invalid value, please input a value greater than 0, just because we are sending the 0. So now I will select this 5. I want to send the 5 balance. Okay, and press this send. It says thanks for your transaction. When I press cancel and get the balance, as it is a feature, so it will take some time to show us the balance. And we know that it's doing on the real Ethereum blockchain. Obviously it will take some time. And then we got the 25 balance. We have sent it from here, and when we try to check it inside here also, we are still getting the 25 balance. And our app Flutter app is successfully connected with our smart contract using these Metamask wallet address, contract address, and the web3 client, and all these things. And when I try to withdraw the 10 balance, let's say withdraw, and after some time it say thanks for your withdrawal, press cancel, and again try to get it. Now we have 15 balance. Let's also check it in here. We have 15 balance, and our app is successfully working. So that's how you can create a simple DApp, and you can connect it with Flutter using some packages. So I think that was it for the video. And so if you found this video helpful, hit a thumb on a like button and leave a comment if something is not clear to you. I will tell you in the comment section if you don't understand something in this video. So before saying bye, I will push this code in my GitHub repository, so you can get the code from there. So I have created this repository here, and now I will push this code. Go to the terminal, initialize the get in here, and we will do get commit -m. That will be our initial. Sorry about that. First we have to get add, and then we have to get commit -m and initial, and all the files are added. And the files we have ignored in here will not be added, and you will not see this .env in the project repository. So after that you have to do git remote add origin, and we need the URL of our project repository. dot git and then git branch minus m main and git push minus u origin main, just like this. It will take a while and our code is successfully pushed on the GitHub. So refresh this repository. All the code is here. You can get it easily from here if you want, and I will share my GitHub in the video description so you can get it from here. So goodbye, and I will see you in the next video.